So now that the cell has reached the perchlorate stage, all we did now is we dumped the cell juice in here. We boil it down a little bit, slap it in the freezer, wait for crystals to come out. So I've already done one run of this already. You can kind of see we've got quite a bit of pretty pure chlorate crystals. It's like just a crystallization. Make sure we get all the salt out, that way it doesn't destroy our anodes. There's just a little bit left in there. And since I've already done this one time, this is all the juice left of the cell. I'll show you this, boiling this down and then collecting even more crystals out of this. I like to do this with the remaining solution 2 or 3 times to make sure I get as much as I can out while still having it be pure. So while this heats up, you can do that. Another note is that these crystals are actually quite solid at the bottom, so it's going to be kind of hard to get them out without breaking your beakers. So I just kind of push it and stir it around. That's close. And then after I get all of this sodium chlorate out, I'm going to go ahead and put it in here just for a minute while we process the rest of this. Then we can start another cell run. Another thing I forgot to mention is the sodium hypochlorite, or the hypochlorous acid. It will eventually get destroyed, but it doesn't hurt to destroy it. You can do it by boiling it for 15 minutes or something, which is usually what we've already done. I think we've destroyed most of it, but to get the last of it, you can actually put some hydrogen peroxide in the solution. And that should destroy the hypochlorous acid, sodium hypochlorite without destroying any of the chlorate or any other important things you're trying to get. Okay. I'll actually take my mask off for a second so I can talk to the camera. I don't think you actually need a mask for this, but I like being on the safe side. Yeah. But I went ahead and scraped all the beakers into there. It took a good minute, but that is pretty much very pure sodium chlorate. The shadowing makes it look a little bit dirty, but it's actually very pure. And then the remaining solution is boiling. Restoring any more hypochlorates. I think we got them all, like I said, and now just reduce the water content a little bit. I should have another solution to go ahead and put in the freezer and get even more crystals out of. So I will cut to once this is finished boiling down. Okay, this is at a boil now. I'm keeping my mask on a little bit longer. Boiling all this pretty much bleach solution is not really chlorine in here, so keeping that on. So we got all this. We've got a beaker at the funnel right here. Normally it's not a good idea to put hot stuff in glass, but this is the chemistry glass, so it's able to withstand some pretty high temperatures. I've done this multiple times, haven't seen any cracking yet. So we just pour it in. I've actually reduced the water, maybe too much here. Take this. So now we just have to wait for this to cool and all the crystals should come out at the bottom. It takes a good couple hours. You can speed it up by putting it in the freezer like I'm going to do. But once that happens, you just pour off the top, put it back in the pan, boil the water down a little bit more, keep making crystals until you can also test it until there's just salt. Alright, I just took our solution out of the freezer here. It's kind of hard to see. Let's see, where's my rod? You see it's formed like a little salty crust on the top here. Let's just knock that down. The solution. You can see we get about that far and we hit solid purified sodium chlorate crystals. So I'm just going to pour that back into our pot here. So far this is how much sodium chlorate we've gotten from just 2 runs of the cell. Haven't weighed it yet, but it's pretty solid bag of chlorate. I'm going to electrolyze that one more time. So drop that in here. little bit more. Then you can see here is our crystals. What I've been doing with these, now that these are a little bit more watery than I thought, these should be pretty pure. I just go ahead and heat these up and drive all the water off, and then we have the powder here. A tip I will give is do not use wood to stir nearly molten sodium chlorate. It caught on fire and almost exploded. So don't do that. I'm only doing it because I'm very desperate right now. I'm doing it at low temperatures. But yeah, that's that for now. Okay, so now for this part we have our pure bag of sodium chlorate. I've already put a bunch of it inside. I ended up with almost a quart of it. I know that's not really a scientific measurement, but that's the only measurement I had. Probably should have weighed it. So now I'm just saturating a solution of sodium chlorate inside here. And then once this reaches saturation, this will go inside my electrolysis cell. So we have the jar here. Now I've cleaned this all. Go in there and we'll start the next electrolysis jump. I'll cut to as soon as I dissolve a little bit more sodium chlorate in here. I'm just trying to get as close as I can. And we'll go from there. Alright, we've got all the sodium chlorate dissolved. According to my math, because I didn't actually measure the weight, I had 600 grams or 600 milliliters of water I dissolved it into, and I dissolved about 1.3 kilos of sodium chlorate inside. So it should be saturated right now. So I'm going to go ahead and load this into the cell. But also with that math, I noticed that I have so much sodium chlorate left over. Just from 2 runs from this cell, I might make a video of how to make it later. We made about 2 kilos of sodium chlorate, so about 1 kilo a run. Quite proud of that, honestly. So, go ahead and put this in. Actually, now I'm thinking about it, that is not Perchlorate chemistry glass, so I'm going to put it in here in case it cracks. Yep, not going to do that again. Had those jars cracked 2 times already. Perfect, right to the 800 milliliter mark. That is perfect. The pan is, Teflon pan is clean. All right, so now that we have that, let's see, I'll put that in there. Just have to put on the lid. Oh, maybe I'll get it. Absolutely beautiful. I am so proud of that. So there we have 600 milliliters of water, 1.3 kilos of sodium chlorate, all attached to our power supply. This has a max of 5 amps, a lot lower than most perchlorate cells run at. If I'm right, it just means it should take a little bit longer to do, but as long as it reaches the voltage of, I think it was 4.5 to 6.5 volts is about where perchlorate cells run. It shouldn't really matter what the amperage is, it'll just take longer. So go ahead and power it on now. And wow, voltage is actually a lot lower than I thought. I bet it'll start climbing later. You can see that it's starting to oxidize it one step further. So I don't really think that chlorine gas will escape. That's more of a step for just the chlorides. Just to be safe, I'll put this in my base solution. Yep, can't be too careful with chlorine gas. It takes a while for it to fill up the tube and actually start pushing it out. Oh, it's already climbed about 4 volts. So I'll keep an eye on this for the next couple of days and take some more videos as things update. But we should be getting sodium perchlorate here soon, which means we can then branch it off to potassium perchlorate and ammonium perchlorate. And for this video, we're going to be going the ammonium perchlorate route for the rocket fuel. This is an optional step. You don't have to do this, but I'm going to heat up the rest of the chlorate that was in the bag just to drive off any extra water that was in there, because sodium chlorate is extremely hygroscopic, and it looks like it's already began taking some water out of the atmosphere. So I'm going to just heat it up, try to drive off any hydrates that there are, and then keep that in storage for any projects that may need chlorate in the future. So that's an optional step if you have any leftover chlorate like I do. I turned the cell off recently because the voltage stabilized. I read that the voltage when it stabilizes actually means that it's about done with the perchlorate producing process. I didn't know that the first time, so I kept letting it run for a couple days after it peaked at like 5.5 volts, and then actually kind of destroyed an electrode on accident. It's kind of hard to see, but that definitely is titanium there. It burned off the platinum. Luckily, the other side is also platinum, so I just switched it. But yeah, if it's stabilized, leave it for a day, maybe less, before switching it or turning it off, because otherwise it'll ruin it. But here we should have a bunch of super saturated sodium perchlorate solution. I topped it off with sodium chloride a couple times, so as you can see the temperature decreased and a bunch of it precipitated out. Looks a little bit dirty on top, not sure what that is. But I'll go ahead and boil it down to get all the water out, and then from there I'll do a crystallization using some acetone. I will get that out. This is a little bit dangerous because that is a fuel and this is the oxidizer, so it's kind of a bad idea, but I'll try to do it as safe as possible in very small amounts. So I'll show you guys that. Okay, I have the setup here. I have my Teflon pot that I will be using to cook it in. For those of you who are a little bit less familiar, Teflon is very chemical resistant, so it makes a really good container for holding things, or in this case actually cooking them. So I'll go ahead and take my perchlorate liquid, dump that in there. Okay. Whoa, beautiful perchlorate crystals, and a lot of them too. Wow, it definitely feels very heavy. Okay, so I'll just start off with the liquid now, and then once this boils off, because this will take a good while, then I'll move on to actually getting the water out of the rest of the chlorate, or perchlorate. From what I understand, when it is allowed to slowly precipitate out like this, not under heat, it shouldn't form any hydrates. You guys can correct me if I'm wrong on that, but this one should be pretty water-free right now, but just in case, I'm going to cook the water out as much as I can. So let's start this up. Okay, we have it at a boil now. It should just take a couple minutes, and maybe like 30 minutes, and all the water should be out of this one. Okay, here we have a bunch of perchlorate. Looks like most of the water has come out of it. It's pretty splashy though, so you gotta stir it quick. It looks like some kind of like fudge almost, like a really cursed fudge. So we're getting pretty close here. I think I'm gonna turn off the heat soon, and then cook the water out of crystals. Okay, we got the perchlorate dry as a powder now. I'm gonna go ahead and weigh out about 5 grams. We're gonna dissolve in acetone. It is very soluble in acetone. Per regular sodium chlorate, I read an article about it from 1945. It was about 0.1 grams per 100 milliliters. I'll try to remember if I can link that in the description if you guys are interested in that. As far as I know, regular sodium chloride is not soluble in acetone, so the only thing that should come off should be the sodium perchlorate. And then by how much is left, we'll be able to determine the purity of it. Okay, this is the part that determines everything. If we've actually made the perchlorate. A little bit nervous since I've spent a couple months on this project, but we're gonna see. Got a little under 50 grams of acetone, 50 milliliters of acetone in here, which should be more than enough to dissolve all the perchlorate. Okay, we got that. I'm gonna grab my spoon, stir it around. Okay, definitely looks like some of it's dissolving. Just gonna try and grind it up a little bit. Oops, a little bit came out. Okay, it's definitely dissolving. We've definitely made some amount of perchlorate. So once it's all dissolved, we can just filter off the extra powder and weigh it, and then we'll know. After a little bit more stirring, I actually found that there is nothing that did not dissolve that I can see. So that probably makes sense why my anode burned through so quick, because there was almost no chlorate left in it. So that should be all perchlorate, along with pretty much this whole pot. So I think we have probably not 2 kilograms of perchlorate. I'm obviously going to have to double check that and measure it, but this method seems pretty high yielding. The warning once again, definitely keep flame away from this because it's oxidizer and a fuel, like dissolved in the fuel, which is not very safe. As long as you're really careful and don't heat it up to drive off all the acetone too hot, you should be fine. I'm actually going to run this through my distiller once I have a little bit more to run through. Right now I have some sulfuric acid in there, but I'm going to go ahead and dissolve all of my sodium perchlorate in here with the acetone and then very gently heat it up through here, and then have it condense into a flask. That way I can keep reusing the acetone without wasting it. So I'll show that another day. Another test we can actually do to see if there's chlorate inside of it is to put hydrochloric acid inside of it. So the acetone pretty much confirmed that we're at really high purity chlorate, or perchlorate I mean. But I still have a couple other tests I'd like to do just to show you guys and also to 100% ensure that I have 0 chlorate in there. That way when we end up mixing the ammonium chloride, we don't accidentally make ammonium chlorate. So I'll go ahead and take some hydrochloric acid. Okay, and we'll just drip it in here and it'll turn yellow and smoke a little bit and smell chlorine if there's chlorate inside, and if not, it won't really do much. So I'll put a lot in there actually. And if you can see in there, it is not turning yellow. I don't even smell any chlorine either. So yeah, that's a pretty much, I can smell a tiny bit of chlorine. Like 1% chlorate in there. A little bit yellow actually, just a little bit. But that still pretty much confirms like 95% plus 99% purity sodium perchlorate.
Cool! So acetone is really cool when it burns?
Yep, just kind of burns like that. Nothing too special.
That's cool. You can use that in the alcohol lamps.
Okay, and now I have about the same amount of acetone with a little bit of a couple grams of perchlorate dissolved in it. So this is the worst case scenario if when you're distilling something happens. Thought I'd record it so you guys can see. Alright, let me just... Well, it's a little bit windier right here. Oh, you can hear the perchlorate starting.